Right, GATE 2013. It is my favorite question in GATE. Right, consider two rockets P and Q. Consider two rockets P and Q fired vertically up with identical specific impulse and payload of payload 2 kg. Full stop. Rocket P has two identical stages. Each stage has 200 kg of propellant and 20 kg of structural weight. Full stop. Rocket Q has a single stage with 400 kg of propellant and 40 kg of structural weight. Full stop. Neglecting drag and gravity affects the ratio of change in velocity of P to that attained by Q is leave a blank. Come on, guys. So the given story is like this. You have the rocket P, which is like this, and you have the rocket Q, let's say, which is having single stage like this. Let this be the rocket Q. Okay. So mass of the propellant in rocket Q is 400 kg and mass of the structure is 40 kg. Whereas in Q, the mass of the propellant, you have to add up both per stage it is given. Okay. So let's solve for first rocket P. So what will be this? This discarded mass will be the structure of 1 and the propellant mass has to be subtracted. Fine. First you write rocket P. You try this. So before staging, the initial mass is m01. After staging, the initial mass of this would be m02. Mass of the structure left out is ms1. That is discarded before igniting the second stage. So you write initial mass of stage 1. So at the beginning of stage 1, what is m01? It is the entire rocket is carrying two stages. Each one has a propellant mass mp1 and it each has a structural mass ms and the payload is mass is ml. Each stage propellant is 200. Each stage structure is 20. Payload is 2. So you will be getting this as 442 kg. That is M01. Okay. M01 is 442 kg. Okay. Then you write initial mass of stage 2. And the first stage is over. This much is released. Okay. And the propellant is burnt also. So the initial mass at stage 2 would be M01 minus MP1 minus MS1. Do that. That will become 442 minus 200 minus 20. That will be 222 kg. That is M02. Okay. So what will be delta V total for rocket P? It will be delta V1 plus delta V2. Delta V1, both the ISPs are same. So I'll simply write ISP ln of M01 by M01 minus, what will be this? MP1 plus ISP into ln of, both the ISPs are same. If they are different, you can write like this. M02 by burnout mass will be M02 minus MP2. Write that. So what is the ISP values they have given for per stage? Check. Did they give the ISP values?
So it is same,
No,
sir.
it's same. So you just calculate ISP into ln of ISP into ln of 442 by 442 minus 200 plus ISP I have already taken common. Ln of M02 is 222 by 222 minus 200. Rocket Q liquor, right? Rocket Q. It's a single stage rocket. Okay. Having the initial mass. How much is the initial mass? MP plus MS plus ML. 400 plus 40 plus 2 for rocket Q. That is 442 kg again. Okay. So what is delta V total for Q? This was delta V total for Q is the ISP into ln of M0 by MB is M0 minus MP. Okay. So that is ISP into ln of M0 is how much? 442 divided by 442 minus 400. Give me this number.
So 2.353, sir.
2.353 ISP. That is delta V for Q. Delta V total you write. Is the delta V total for Q. So therefore, delta V total for P divided by delta V total for Q is 2.9129 something you will get. ISP divided by 2.353 ISP. Cancel out these two and get me the value.
1.238.
1.2379 will get. Right. GATE 2013. Then we'll do one more of 14 also. Right. A rocket motor has a chamber pressure of 100 bar and chamber temperature of 3000 Kelvin. Full stop. The ambient pressure is 1 bar. Full stop. Assume that the flow in the nozzle is isentropic and optimally expanded. Full stop. The exit static temperature is in Kelvin is leave a blank. चलो बी क्विक. ये लोग ने ऑप्शंस भी दिए 805, 845, 905, 945. So T by Tc can be written as P by Tc to the power of gamma minus 1 by gamma. So you will get T as 3000 into 1 by 100 to the power of 0.4 by 1.4. You will get this as 804.86 Kelvin. Hope you all are through. Everybody